Okay, here we're going to try something that you probably may not have studied before in statistics. Maybe you have, but not going to worry too much about that. Just see what a little bit about R. Okay, first of all, there's some data sets that come with R, and you don't have to do anything to get them to run. I don't think you even need the library function to get them to run. And one of them is called empty cars. I'm not sure what MT stands for, but it's about automobiles, about cars. And if you want to see a little bit about that data set without seeing the whole thing, you can type summary MT cars. Or you can also type like this. I think it's either head or header. Let me check. So it's head, and so it's actually a data set, and this tells you the first few rows of this data set. So we can see that the first row is about a Mazda RX-4, and the next row is about a Mazda RX-4 wagon. The next is a Datsun 710, and a Hornet 4, and a Hornet. Anyway, so these are different cars, I guess, and then some data or statistics about these cars. For example, how many miles do you get per gallon? 21 miles per gallon. This one is only 18.1 miles per gallon. So this one gets better mileage, goes further on the same amount of gas than this one does. And this is the number of cylinders and the size of the engine. This is called the displacement, and the horsepower. It's like the power of the engine. And I don't know all of these things, but these are different different information about each of these cars. And then we also typed in this. Let's do it again. And then we get summary statistics about the cars, which usually means like the minimum, the maximum, the mean. So like for miles per gallon, the minimum miles per gallon was in the whole data set was 10.4. Now in this, just the header part of the data set, that's just the first few rows, the minimum was what? Was like 18.1. But if we look down through all the data, the minimum would be 10.4 and the maximum would be 33.9. And then there's other things like the mean, average miles per gallon, and so on. And you have the same thing, min, max, mean, and so on, for all of these columns. So for the cylinders, what's the minimum number of cylinders, maximum, and so on. Okay, so you can get some idea about this data by doing that. Now we're going to use this data in the following way. We're going to run what's called a simple linear regression. So basically, in this linear regression, we're going to wonder, is there a relationship between this variable and this variable? Now, this variable we just said is miles per gallon, and this one is the weight, I think. Let's look at it again. So here it is, the weight, probably in tons, I guess. And anyway, you would think that there's a relationship between how much, well, the mileage that a car gets and its weight. So if it's a much bigger car, it should get less mileage. But we'd like to know is what is the relationship and how strong is the relationship, and that's what that's basically what linear regression can tell us. So maybe before we do this regression, though, maybe it would be good to look at a plot of or graph of the two variables, weight versus MPG. So why don't you try and do that first, see if you can remember how to get the picture where the x-axis would be the weight and the y-axis would be the MPG. And we're hoping, remember, that as weight increases, that the MPG should decrease. That's what we expect, rather. So hopefully that will show up in the graph as well. So why don't you pause the video and see if you can work out how to do it. Now, it's not quite straightforward because you have to do something that you learned, I think, last week in terms of accessing the variables in a data frame or in a data set. So we learned about it last week, I believe. So you're going to have to use that here. So why don't you try and do it though. So pause the video and try. Okay, so how do you do it? Well, you might have tried just to do, let's see, here's the MPG and here's the symbol for weight. So you might have tried to do plot WT comma MPG like that, right? But you would have found that that didn't work. It doesn't know what WT is and it doesn't know what MPG is. But it does know about this data set, which is a data frame actually. So how can you get it? So you have to do like this, right? MT cars $, remember that, and then weight, we want to do weight, comma MT cars $, MPG, right? And then when you do it, you get this picture here. And it shows basically what we expected, which is that as the weight increases, the miles per gallon decreases. Okay, so now that we've seen the picture of it, let's use regression to test it, to do a little bit further, stronger analysis. So the linear regression function is LM. So let's try to get some help on the LM first. So what do you do to get help? So hopefully you remember. Like this. And this stands for a linear model. And LM is used to fit linear models. Can be used to carry out regression or single stratum analysis of variance, or analysis of covariance. But we're not going to be doing that. Okay, so here's the command or the function, and then the arguments are here. So here's the formula that we're going to be using. That it says an object of class formula, that's not so clear, or one that can be coerced to that class, that's not so clear. A symbolic description of the model to be fitted. The details of the model specification are given under details. Okay, data, an optional data frame, list or environment containing the variables in the model. If not found in data, the variables are taken from the environment formula, typically the environment from which LM is called. I think we need to specify the data though. And then there are other, number of other. By the way, the dot dot dot, I once mentioned it before, but it's actually the additional arguments to be passed maybe to the function. So these are kind of extra arguments. Anyway, let's not do that. But let's see, what's this say? Details. So, alright, let's go down to examples. And here we have a vector of values, and here's another vector of values. And they're contained in here and here. And here they're doing, they're looking at, oh, here's two more, sorry. There's another and another. And so here they're doing, I believe it's a regression, might not be a regression actually, but this variable compared to this variable. Okay, so let's go back and look at this. So this is how you do it, regression. Now, let's try it. So let's type this in. Now, this character here is called a tilde, and on my keyboard, it's the last character on the left, on the upper left, just below the escape key. So maybe that's where it is on your keyboard, I'm not sure. And then we're specifying the data here. And let's try and run this. And here's the output. Okay? So how do we read it? So what it's saying is that basically what we're trying to do here is put a line in here that sort of approximates this data, a straight line that sort of approximates this data. And the straight line, so a straight line of course has an equation. Usually we'll write it something like this, and this means that m is the slope and b is called the y-intercept. So here the slope should be negative, right? And the b-intercept might be something like up here, so it could be maybe 35 or 38 or 40 or something like that, right? So what we want to do is fit a line to this, and that's what linear regression will do. It will fit a line to this. Linear regression will fit a line to this. So all we need to know then is what line it is, and that means all we need to know is the equation of that line, and that means all we need to know is the m and the b. And that's what it tells us here. So the m is the, well, remember this is like this, right? It's not y really, it's mpg is this axis, and and x is wt is this axis. So this is really what we're looking for. And so anyway, but still, m we want to expect to be negative, and b we expect to be around 40. So what are the actual numbers? M is negative, and it's negative 5.344, and b is 37.28. So really the equation is, according to this, is mpg equals negative 5.344 times, 0.344 WT plus 37.285. Oops, that didn't work. Okay, there. So that's the equation of the line that fits this, and that's what regression tells us. Okay, so you can do that fairly simply just by doing this. Now, how would we plot this line? Well, we talked about plotting a line, so we could try to do it using the methods from I think it was the last video or 2 videos ago. But there may be other ways to do it as well. Okay, in the next video we're going to just look at this output a little bit more, or look at this using this LM, the results of the LM just a little bit more, but I'll stop here and restart.